I had my first Haskell job, and we used property-based testing, and some people ran 100 tests, and some people ran 1,000 tests, and some people ran 10,000 tests, and I was like, how many is enough, right? So I ended up asking my friend Chris Smith, and he said, the way to find it out is to turn on HPC, and then you go look at the pretty colors, and you figure out, like, did your code get covered? And then I had to go play around with my Cabal properties and turn on HPC or turn it off. And I was like, what would be really great is like if the computer just did this for me, right? Like, can I just get the computer to do it for me? And so about 6 weeks later of like learning all kinds of things, playing with event log, doing all kinds of other things that did not actually work out, it turns out that HPC at runtime can reach into the RTS and just get the counts of all of the regions that have been executed. So HPC, what it really does is each of your regions inside there get one little integer. And so my choice for answering the question of how many tests is enough is I just keep running as long as code coverage increases. And so that was like each of these little regions inside each of these little regions that you get back from HPC. This is my whole library. It is almost nothing. It's great. And really, the whole exciting part is that you call examine ticks here, and that gives you back this list, an IO list of a bunch of integers. And if more of them have become non-zero than the last test, then keep running tests. And so that's pretty much it.
Cool.
Wasn't that a great short talk? Yeah. Okay. Any questions? Joachim?
So if your tests are randomly produced just because it didn't bump in one iteration, doesn't mean there isn't a good chance that maybe the second test after that increases. So do you really just stop when it doesn't increase once, or do you like keep running for like another 1% extra and
Yes. In fact, the grab until n same, you can pass it however many you want. And I decided 40, just kind of like trying it out. 40 seemed to be fine.
I would recommend 42.
Oh, absolutely. No, you're right. That's a good choice. Yeah. Let's go.
So I'm curious, what in your examples, what's the right number?
What's the right number?
Yeah, I mean, just in practice, like when you start doing this, are you running 10 tests, 100, a million? What's actually happening?
So it turns out that I supported 3 different things because I wanted to compare them. So I've got Hedgehog, and I've got Lean Check, and I've got Quick Check in here. And you can tell that I had a lot of extra fun with Quick Check because I had snippy comments in there. And Hedgehog was okay. And one of the things I found interesting was like how quickly does it converge? What is kind of like you've got as much coverage as you're going to get. Lean Check got there like super fast, and so I've been using Lean Check for a lot of my stuff since then. Was that kind of the question you were asking, or like how many was enough, or?
No, I mean you're saying I don't want to pick a number, right? I'm just going to run it until, but then there's an implicit number, right? Like the number that you end up with. So I'm just curious what that number is.
I think it's going to depend on your code base.
Yeah, of course it's going to depend, but maybe in yours, I mean, just a ballpark. I mean, I've just in your examples, because I could imagine maybe it keeps running forever, or maybe it converges very quickly, and if it converges very quickly, then is that? I'm just curious.
I don't have a good answer, but you know what? I will find out because now I'm curious too.
You didn't run examples?
Well, I mean, I ran a bunch of examples, and so like.
So how many tests did it run on those examples? Give me a number, man.
Okay. Let me think. I think it was about 60 or 70 was actually how many random tests. But it also depended on like what you're using to generate, right? So like Lean Check is enumerative, and like Quick Check is just whatever, right? So it just depends on how it gets generated.
You said you compared at least 3 different property testing libraries. Did they actually converge to roughly the same, or comparable coverage results?
They did.
Okay, that's good.
Quick Check took a long time to get there.
Yeah.
And Lean Check was really fast, and Hedgehog.
But they're the same sort of. They covered the program equally.
Almost every time.
Good.
Yeah.
It's reassuring.
Any other questions?
Is it available on package?
Oh, absolutely. Yeah, Kudzu. Kudzu will cover all of your bugs.
Okay, let's thank the speaker and then
All right.
we're done.
Real quick before we depart, I want to give a special round of thanks to the AV team for their absolutely heroic efforts to make this work. This would not have been possible without them doing some last-minute bug fixes and figuring out what's going on in everyone's laptops. So huge round of appreciation to them for making this work. Still, I insist. I also want to thank Ben and Yavor for volunteering to be session chairs at more or less the last second. So thank you so much for that. And thank you to everybody on the program committee for reviewing all the talks and curating the program that you got to see. And thank you for attending as well. This has been really fun. So I'll see you all in the hallway.